Welcome back. So this is gonna be the second part of the screencast where we're gonna do the actual refactoring. So before we proceed, let's run all the tests to see if we're green. All right, and so we can now start with the actual refactoring. So as mentioned in the first part, what we can do is we can first start by delegating the different responsibilities in different functions. We already did that for the fetching in order to create a scene. So let's do the same for filtering. So filter items. So this is gonna be okay. Items and keyword. Then again, I will make the return type explicit and then make a return here. That would be the filter function, and finally I can also extract this one into a function, reorder items, and also I'll do the same renaming here. It already does has the return type and all. And now what we have from the search function, this IntelliJ is suggesting me to do the inline here, and I also don't think that I need to explicitly put the actual type here because of the type inference. So all works fine. So let's take a look now. Here the method works, it operates on the same level of abstraction, and it just what we came up with is what's called compose method. It just delegates to another methods. So this is nice, and we can run the tests to see if all works fine, but we're not quite there yet. So first let's check in. Not separated, but maybe pushed different responsibilities into separate functions. Okay, so if I want to change the way the items are loaded, I have to change this class. Also, if I want to change the way the items are filtered, for example, now I have the contains, but if I want to, for example, do the exact match, I'll have to again change this class. And the same applies if I want to change the ordering. I will have to make change in this class, which means I have already at least 3 reasons to change the same class. That violates the single responsibility principle, and that is a problem here. So what we can do is actually extract these different responsibilities in different classes, in different types. One thing that I have to mention is that when working with Kotlin, a bunch of refactorings that are available for Java are not available for Kotlin, so we'll have to do most of the refactorings manually. So let's see how that will work. So essentially what we are trying to do is come up with collaborators for the searcher that are so the searcher is just gonna delegate to those collaborators. So let's start off by creating a class here that will be, I'll name it remote inventory, and I'll just copy the same function here, and this is unused, so if I run the tests everything works fine. And here, instead of doing the external system fetch all items, I'll delegate to that new class. Yeah, and if I run, it should still work. Cool. So what I will do now is I will make variable. So yeah, here again I don't have a refactoring to move this into a constructor, but so let's make sure. Yeah, and if I do move, it doesn't work. So what I can do is do this, and now I can move it to constructor. So I can make this private, and nice, like cool thing in Kotlin is that I can initialize it by default to some implementation, so whoever is using this class is not gonna break. So if I run the tests, everything should still work. Cool. So what I'm trying now to do is I'm trying to switch the theme from this class to the inventory. Then I think I'll just extract this into a standalone class, make it bigger. Good. And now I think it still works. And now I'm gonna try to eliminate this theme and replace it with another one that I'll create for the remote inventory. So here in the test, here for the inventory I'll pass an in memory and I'll pass the all items. Of course this class does not exist. Let's create it. So it will take all items and it derives from, yeah, I need this to be private val. Oops, why did it create a function? I want it to be a class. Oh wait, let's back this off. I think I know why. And then all items. Create function. The problem most probably is that the remote inventory is not open, and I need, anyway, because I'm gonna be overriding this function which is open, I have to make this one open. And now, yeah, now it allows me to make a class. Cool. I'll make a value and then derive from the remote inventory and then override the fetch items and return the all items. So far so good. If I run, all should still work, which means if I comment out this one and run, it should still work. And then I can basically eliminate all of this and run again. All good. Again, here I don't have the inline. Yeah, the inline is not working for a class. But what I can do is I can actually use this one, copy, make this a little bit smaller, and then go over the tests one by one and replace. So here, instead of the testable searcher, I'm gonna use the actual searcher instance and then pass in memory with no items. And if I run, it should still work. Cool. here would be the same, and here I need all items, and if I run, yeah, and then the same would apply here, searcher, then in memory inventory all items, run, and the same here. And now I run all the tests, I'm green, which is cool. And now this class appears unused, I can delete it. So I switched the theme from the actual searcher to the in-memory inventory, and now here I can actually eliminate the theme. I can inline the call, and if I run, it should still work. Exactly. And I can also remove the open modifier on the class. Cool. So I think now it's a good time to check this in. Pushed the, well, emerged inventory type for fetching items. Well, that was not perhaps the best wording. Maybe I should have said something like pushed fetching responsibility or something, but yeah, I think it's fine. Then let's proceed. Let's do the same with the filter items. So I'll create a class contains filter, and I'll pull this in, and here do contains filter items. Okay, this is private, I should make it public and then run the tests. That's good. I can push this class outside. Oops, not the tests, this one. So it looks fine. And run the tests. All good. And then I'll do the same for this. I'll create a variable here, and then I'll move it here so I can move the constructor. So also I'll use the default here, so the users of searcher are not gonna break, and I'm green, which means I can also check this in. Emerged filtering collaborator. And finally, let's do the same for the order. Keyword matching order. So keyword matching order, move it here, and then remove the private modifier. Keyword matching order, reorder. If I run the tests, all should be fine. And then same to create variable here, and then, well, I can directly move it. Cool. And then let's run green, and I can also push this one outside, make it bigger, and I also prefer to, I hate using these sort of abbreviations here, so left, right, and I think I can replace this one with lambda. Yeah, it looks a bit better, a bit more concise. Let's run. All green. Cool. So let's check this in as well. Merge and ordering collaborator. Good. Now what we ended up with is this search method is still a compose method, and it just delegates to some of the collaborators to do the job, and now we are at a way better place. However, there is still something that we can do. Basically, this concrete implementation is also depending on concrete implementations. That means that if we happen to change some of those types, we will also have to make a change here in this class. It would be way better if we depend here on abstractions instead. So we are gonna apply the dependency inversion principle. How we can achieve that is here, if we extract here, actually this refactoring works, thankfully. So what we can do, we can extract an interface to a separate class. I will name it inventory, and then I'll also include the fetch all items function in there. So here is the interface. I don't need the open modifier because that's what the interfaces are for. All the things are open by default there. So the remote inventory is depending on the inventory now, and then basically what we can do in the searcher, instead of the remote inventory, we can depend on the interface, and then again instantiate the default here. If I run the tests, everything is green, and then here I no longer need the class to be open, because here in the test, instead of the remote, I can directly do the inventory and then override for the in-memory. And then if I run the tests, I'm still green. So what I can do right now is I can do the same for the filter and for the matching, and basically I prefer to do that instead of checking in after every single refactoring of this type, because it's sort of safe and I know it's gonna work. So I'm gonna right now I'm deciding to make a bigger step. Okay, so again, here I do extract interface into a separate file, then I name it filter, and then here is the interface. I think it looks fine, and this, the contains filter, derives from the filter. So also here I do have to depend on the filter type. Yeah, if I run, I'm still green, and finally the same will be done to this one. So we have an order, we want the function. If I make it bigger, I think all looks good. Here is the implementation, and then here I'm gonna depend on order. Now I'm gonna check this in. Searcher depends on abstractions rather than concrete implementations. So what we ended up now is we are at a way better place. So now, for example, if you want to change the order, we can write another implementation of the order and pass that one wherever the search is being constructed. So where we need a different search when constructing the searcher, we can pass that one. We are not gonna touch this class anymore, and that's why we are at a way better place. So I think we are done for this exercise, and I think the moral of the story is that sometimes we have some code that looks kind of small, easy to refactor later, and the key point is to take some 10, 20 minutes, 30 minutes, do pay that effort at that time and make the code better rather than keeping it for later. These sort of small things pile up over time, and eventually it's gonna be way harder to solve all that and get the code to a better shape at once, compared to doing that constantly over time. So I believe you liked and you enjoyed this session. I'm very open for feedback, and thanks for watching.